Welcome to Wildfires in the West, an EcoWest.org presentation. EcoWest's mission is to inform and advance conservation in the American West by analyzing, visualizing, and sharing data on environmental trends. This is one of 6 presentations that illustrate key environmental metrics. Libraries for each topic contain additional slides. You can download this presentation and other libraries at EcoWest.org. Let's begin with a summary of this presentation. Wildfires are natural in most western forests and critical to maintaining ecological health. They're behaving differently today in some western ecosystems due to the legacy effects of fire suppression and other human activities. They're growing larger, burning longer, and becoming more intense in many parts of the West. Climate change will exacerbate these trends. They're posing increasing risk to homeowners in the wildland-urban interface, threatening some species in forests and woodlands, and leading to increased flooding and soil erosion. They're costing us more to suppress and consuming much of the Forest Service budget. They're prompting thinning projects to reduce fuels in overgrown forests, but not without controversy. And they're compounded by other stresses on western forests, such as a changing climate and insect outbreaks. This PowerPoint presentation is divided into 7 sections. First, we begin with a discussion of Wildfires 101, and then show some slides related to recent fire history in the West. We discuss the suppression of wildfires, efforts to thin fuels in overgrown forests, and the wildland-urban interface, where homes and businesses are especially at risk. Climate change and its impact on wildfires comes next. And finally, we conclude with a discussion of insects and forest health. Let's begin with the basics of wildfires. 3 ingredients are needed for a fire: heat, oxygen, and fuel. The job of wildland firefighters is to knock out one or more legs of this 3-legged stool. By dumping water on the flames, they're reducing the heat. By smothering the fire with dirt, they're depleting the oxygen. The bulk of wildland firefighting, however, revolves around the 3rd element, fuel. When firefighters dig a fire line with a shovel or use a bulldozer to blaze an impromptu fire road through a forest, they're attempting to remove the fuel. It's the same idea with the intentional fires they set ahead of the main wildfire. Sometimes fuels treatments take place before there's even a fire as a preventative measure, but as we'll see, that's not without controversy. Another trio of factors determines a wildfire's behavior. There's the weather, the temperature, humidity, and wind at that moment, plus the climatic conditions over the preceding months and years. There's the topography, the presence of drafty canyons, south-facing slopes exposed to the desiccating sun, or other features that would encourage burning. And once again, there's the fuel. The type of vegetation, its volume, its moisture content, and its continuity on the landscape. No one can do anything about the weather or the topography. Treating the fuel is the only way to make wildfires more manageable and decrease the risk to both human communities and forest habitat. Wildfires are a natural part of many western ecosystems, but the risk of wildfires varies greatly from place to place. In some regions, such as the California desert, there isn't much fuel to burn, though some parts of the Southwest are being invaded by non-native grasses that are flammable. Aside from the West and Alaska, states in the South are most likely to burn. It's important to remember that western forests, woodlands, and grasslands vary greatly in their natural fire regimes. In some, wildfires used to be a frequent visitor, returning every few years, while others would burn every few centuries in big, stand-replacing blazes. Fire is essential to the health of western forests, but for more than a century we have been fighting blazes to protect lives, home, timber, and other resources. The policy was epitomized by Smokey Bear, who helped Americans adopt a negative attitude toward wildfires. But the result of fire suppression was a tremendous buildup of fuel in many western forests. Areas that once burned with low-intensity ground fires every few years now went decades without seeing any flames. To understand the issue, it's critical to go back in time. Western forests have undergone some dramatic changes over the past century. Logging and other human activities have certainly led to the outright loss of some forested areas, but even places that have escaped chainsaws and bulldozers have changed in character. This sequence of images shows how one spot in the Bitterroot National Forest in Montana changed from 1909 to 1948 to 1989. Fire suppression has caused a proliferation of smaller trees and other fuel that can allow wildfires to burn very intensely and reach into the canopy. In some areas, such as the ponderosa pine forests around the drier parts of the interior West, frequent low-intensity burns used to visit the woods, sparked by lightning or set by Native Americans, and clear out the underbrush. But in other forests, such as the lodgepole pines of the Rockies, infrequent high-intensity burns were the norm. Let's take a look at some of the recent fires in the American West. This map shows all fires that were at least 1,000 acres in size from 2001 until 2009. These are the fires that were greater than 10,000 acres. And here are blazes in excess of 100,000 acres. This map shows the fires that are larger than 250,000 acres. Unlike tornadoes and hurricanes, wildfires don't have a standard scale that is used to measure their destructive potential. But some scientists and land managers are starting to talk about megafires that are especially large and destructive. There is no agreed upon definition of what a megafire is, but these blazes would seem to qualify. The number of wildfires and the acreage burn varies a lot from year to year. Although the government has reported these statistics for decades, the tracking methodology has varied over time, especially when it comes to small fires. As you can see, there was a major surge reported in the late 1970s, and then a sharp drop-off in the early 1980s. But since then, there has been more consistent reporting. Here's a close-up of the past quarter century when the reporting has been more uniform. The number bounces around from year to year, but is more or less steady. In an average year, there are nearly 80,000 wildfires in the nation, but the vast majority of these are small blazes that are confined to a few acres or less. As a rule of thumb, wildland firefighters contain more than 95% of blazes in the so-called initial attack, but the relatively small number of fires that do escape are responsible for more than 95% of the acreage burned. If we look at the acreage burn, we can see that there is a lot of variability from year to year, from around 1 million to 10 million acres annually. But there has been an upward trend in recent years. The orange line represents a 10-year moving average. Another way of looking at this data is to calculate the average size of fires. Because we're dividing the total acreage burned by the total number of fires, we run into the same problem with the change in reporting in the 1980s. But if you just look at the past 2 decades or so, you can see that the mean size of wildfires has been increasing. Here's a close-up of the past 2 decades. This slide only looks at really big fires, those exceeding 100,000 acres. Since 2000, it's been common for there to be 10 or more such fires each year. Let's take a closer look at big fires in the Southwest. In this slide, we've only included fires larger than 20,000 acres. Each rectangle represents a different fire, and the size of the rectangle shows how much acreage was burned. Now, when you stack up all of these large fires, you can see that there really weren't very many in those 2 states before the mid-1990s, but in the past decade or so, they've been a regular occurrence. Rodeo Chetasky in 2002 set a pretty high bar at nearly 470,000 acres, but it took less than a decade for that to be exceeded by the 2011 Wildfire, which burned 538,000 acres in both Arizona and New Mexico. Much of the region has experienced drought conditions over the past decade. 2002 and 2011 were especially bad years. But sometimes wet weather has kept a lid on fires. For example, there were no fires bigger than 20,000 acres in Arizona or New Mexico in either 2007 or 2010. This graphic shows how many acres have burned in various regions since 1995. Because weather patterns often cause some parts of the West to be very dry while others are very wet, down years for wildfires in one region may be up years in other regions. In 2004, for example, Alaska had more than 6 million acres burn, but only about 1 million acres burn in the West. Nationally, the last few years haven't been as busy, but fire experts say that doesn't mean the danger has passed. When drier weather returns, fire activity is almost certain to increase again. Here's what the 16-year average looks like. Alaska accounts for about 1/4 of the total. The southern region makes up about 20%. In the West, the eastern Great Basin has seen the most acreage burned. Another way to break down the data is to analyze it state by state. Here are the 11 western states. One interesting trend is the large number of acres that burned in Nevada from 2005 through 2007. This may be attributable to the spread of invasive grasses in the Great Basin. Many people associate wildfires with the Forest Service, and fighting fires was certainly one of the main reasons for creating the agency. But there are plenty of other land managers that play a major role in fire suppression and treating fuels. This graphic shows that state lands, private property, and areas managed by the BLM usually account for the majority of acreage burned nationally. This partly reflects the lack of Forest Service lands in the southeast and some other parts of the country. So what causes wildfires? Basically, it boils down to two ignition sources, humans and lightning. Over the past decade, more than 80% of all wildfires have been caused by people. But if you look at the acreage burned, humans are usually responsible for less than half the total. So why the difference? Well, lightning spark blazes in very remote parts of the West may consume large acreage before they're contained, and in some cases these blazes are allowed to burn naturally to reduce the fuels. Many human-caused blazes, however, start in populated areas and they're quickly controlled. Here's the regional breakdown for ignition sources. In the East, California, and the southeastern U.S., humans are responsible for starting the vast majority of fires, whereas in the Great Basin, it's 40% or fewer. This regional breakdown suggests that fire prevention programs will be more effective in some places than others. Now let's talk about fire suppression, the difficult, costly business of fighting wildfires. Wildfires are one of the reasons why the federal government created the Forest Service at the start of the 20th century, and over the past few decades, fire-related costs have consumed an increasing share of the agency's budget. Here's how the agency spent its money over the last 10 years. The red bar is for wildland-fire management, but sometimes bad fire years have forced the agency to rely on supplemental and emergency appropriations from Congress, shown here in pink. Aside from fires, the next biggest category of spending is for running the National Forest System, shown in green. How does the Forest Service spend its money on wildfires? Suppression, the hot, dirty, demanding work of fighting fires, accounts for nearly half. Almost a third is devoted to preparedness measures, essentially having enough manpower and material on hand to catch fires before they get out of hand and prevent wildfires from starting in the first place. About 16% goes toward treating millions of acres of hazardous fuels with thinning projects and prescribed burns. The rest is divided among assistance to local fire departments, research, and restoration. A number of federal agencies, primarily in the Interior Department, also spend money on wildfires. For example, the Fish and Wildlife Service must fight fires on its refuges, and the Bureau of Land Management oversees vast areas in the West that have the capacity to burn. The best estimate of these other agencies' costs is from a GAO study that only includes data through 2007. One way of gauging wildfire activity is to look at how many days the federal government was operating under various preparedness levels. The National Interagency Fire Center uses 5 categories, similar to the now abandoned Homeland Security threat level system. Preparedness level 5 is reserved for the most active times, while under level 4, the competition for firefighting resources is a bit less intense, and so on down to level 1, when not much is happening as far as wildfires go. This graphic shows how many days the federal government was under levels 4 and 5. Aside from 2004 and the past 2 years, it's been a challenging time for wildland firefighters. The federal government closely monitors how it deploys its firefighting resources each year, and those figures also serve as a barometer of wildfire activity. Here you can see the trends back to 1990. Type 1 helicopters are larger than Type 2 helicopters, and Type 1 mobilizations refer to the number of times that top-level incident command teams are deployed. Smaller, less complex fires are managed by Type 2 teams. Finally, there are the air tankers that drop flame retardant. These categories tend to move together, but you'll notice that the number of air tankers mobilized dropped around 2001. That's because safety concerns over the aging fleet force many planes to be grounded, even during some very active fire seasons. Wildland firefighting remains a dangerous business, with 1,018 people killed in the line of duty since the Great Fire of 1910 in the Northern Rockies. The government reports no deaths for the next 15 years, which may be due to a lack of data. In recent years, more firefighters have been dying, but that doesn't necessarily mean the profession is becoming more dangerous. There are far more people fighting wildland fires these days, so the death rate is probably lower. All but 2 of the most expensive wildfires in U.S. history have taken place in California, where millions of homes, many of them expensive, lie within the so-called wildland-urban interface. Several fires in populated areas have caused insured losses in excess of $1 billion. Now let's take a look at the key ingredient to wildfires, fuels. This map shows the condition of natural fire systems by terrestrial ecoregion. Green indicates where the natural fire regime is more or less intact, pink shows degraded areas, and orange depicts very degraded areas. In the United States, the coastal mountains of Northern California, Oregon, and Washington, and parts of the Central and Northern Rockies still have intact fire systems, but many parts of the Intermountain West, as well as the Southeast and Great Lakes region, have degraded conditions. Because many forests and woodlands have too much fuel due to fire suppression, the government has been trying to step up its thinning on federal lands. This graphic distinguishes between a couple of different types of fuel treatments. The first distinction is between activity taking place within and beyond the wildland-urban interface. Known by its acronym, the WUI is where property and residents are most at risk of wildfires, although the definition is somewhat contested. The fuels treatment primarily consists of thinning with chainsaws, or mechanical treatments, and prescribed burns, or fire. The total acreage has been climbing in recent years, but it's important to remember that these treatments are just a drop in the bucket. By some estimates, there are 190 million acres of federal lands at elevated risk for wildfires. Prescribed fires are an important tool for reducing excess fuels. On a per-acre basis, they are less expensive than mechanical thinning projects, and they can do tremendous good for forest ecosystems by reintroducing fire to where it is natural. But conditions have to be just right to set a prescribed fire so that it doesn't turn into a disastrous wildfire. That's happened occasionally in the West, such as the 2000 Cerro Grande fire in Los Alamos, New Mexico. And many in the public remain skeptical or outright opposed to prescribed fires because of the risks and the smoke. This graphic shows that the number of acres burned in prescribed fires has generally been increasing over the past dozen years. Most of the burns happen on Forest Service land. Prescribed fires are most common in the Southwest, Northwest, and Rocky Mountains. They're used less often in the Great Basin in California. The federal government used to report on instances of wildland fire use, essentially letting wildfires burn rather than suppressing them. This strategy, meant to consume excess fuel and restore the natural fire regime, is still practiced today, but the government stopped reporting that statistic in 2008. This graphic shows the number of wildland fire use acres in the preceding decade. Most of the activity took place on Forest Service lands, but the National Park Service also allowed a fair amount of acreage to burn. Debates about forest management in the West used to focus on commercial logging, but the industry is a shadow of its former self. This graphic shows how much timber was sold and harvested on national forests starting at the inception of the Forest Service in 1905. There was a big run-up in the post-war era, but then a dramatic decline starting in the late 1980s as restrictions related to the spotted owl and other environmental laws took effect and as foreign competition hurt the industry. As a result, many timber mills were closed around the West, so it can sometimes be a struggle to find facilities to handle trees that are cut as part of fuels reduction projects, especially because most of the trees being removed are small diameter and not what the mills were built to handle. To encourage the private sector to participate in thinning projects, the government has been signing long-term stewardship contracts that guarantee businesses they will be able to gain access to excess fuel in national forests for many years to come. Previously, doubts about the supply and environmental regulations created too much uncertainty and made it hard for companies to invest in equipment. This graphic shows that the number of contracts has been on the rise, with most issued by the Forest Service. Now let's talk about the wildland-urban interface, where property is most at risk. An increasing number of homes in the West lie within the so-called WUI, where wildfires pose the greatest risk to homes and businesses. This map shows the location of the WUI. Every state in the West has some of these areas, but they are especially common in California, Oregon, and Washington. In this map, we show county by county how many homes are in the WUI. Pacific Coast states, where the population is larger, tend to have the most homes in the WUI, but there are also concentrations in Arizona, Colorado, and the Northern Rockies. Some research has called the nation's thinning strategy into question. In one paper, scientists found that less than 25% of all thinning was taking place in the WUI in the West. What's more, projects that were more than 10 kilometers from the WUI were being justified as protecting communities. This graphic shows the official justification for thinning, broken down by how far a project was from the WUI. Thinning projects that are farther in the backcountry tend to attract more opposition from environmentalists, but some foresters believe that fuels treatment in these areas is essential for preventing catastrophic fires and for restoring forest health. Now let's talk about the connection between climate change and wildfires. Climate change is expected to increase wildfire activity in the West. This map shows how various ecoregions are expected to fare if global average temperatures increase by 1 degree Celsius. In many areas, the median annual area burned is projected to increase by more than 100%. Climate change is expected to make the Southwest drier, lead to more severe droughts, and cause a thinning of the mountain snowpack that delays the onset of fire season and supplies the bulk of water in western rivers and reservoirs. Scientists have already found that the warming experienced over the past few decades in the West has led to an increase in wildfire activity. One paper concluded that large wildfire activity increased suddenly and markedly starting in the mid-1980s, with most of the change due to a warming climate rather than fire suppression. Higher temperatures led to a thinner snowpack that melted earlier in spring, leading to more flammable conditions in summer. The scientists looked at more than 1,100 large blazes that broke out from 1970 onward. Compared to the 1970 to 1986 period, wildfires in the 1987 to 2003 timeframe were 4 times as frequent and burned more than 6 times the acreage. The length of the wildfire season increased an average of 78 days. Wildfires are bound up in the larger issue of forest health, so let's turn now to the issue of tree mortality, climate anomalies, insects, and disease. Around the globe, forests have been experiencing die-offs that scientists attribute to drought and heat waves, both of which are expected to be on the rise in many parts of the West due to climate change. This map shows the location of dozens of tree mortality episodes that scientists have documented. The different colors represent varying types of drought and temperature anomalies. Here's a close-up of the West. In southwest Colorado, multi-year droughts with high spring and summer temperatures are thought to have caused the cases of tree mortality. Along the Mogollon Rim in Arizona and New Mexico, multi-year droughts with high temperatures were also linked to tree mortality. Insects and other biotic agents often play a major role in forest die-offs. High temperatures or drought conditions can weaken trees and make them more susceptible to infestation by bugs, some of which are native, some of which are exotic. In this map, hollow dots represent die-offs with no connection to biotic agents, and gray dots indicate where no biotic agents were linked to tree mortality. But at least in North America, many of the tree mortality events were connected to bark beetles and other biotic agents. In this close-up of the West, you can see that bark beetles were connected to forest die-offs along the Mogollon Rim in Arizona, while wood borers were an influence in southwest Colorado. In California, other insects were linked to the climate-related mortality events. This graphic shows where 3 of the most common types of bark beetles have been active in the West. The spruce beetle has been fairly widely distributed, but the mountain pine beetle has primarily affected the central and northern Rockies, from Colorado up through British Columbia. The pinyon ips beetle has killed millions of acres at lower latitudes. In this map, you can see the combined influence of fire, shown in red, and insects, shown in orange, in Arizona and New Mexico. The relationship between insects and fires is somewhat complicated. A bug-killed forest may be initially more flammable than a healthy forest, but over time, dead pine needles drop off the trees and provide less potential fuel for a canopy fire. In 2010, more than 9 million acres of U.S. forests were suffering from tree mortality, 74% of which was caused by the mountain pine beetle in the West. The other top mortality agents were the fir engraver, subalpine fir mortality, spruce beetle, and the western pine beetle. This map and the ones that follow look ahead to the next 15 years. About 58 million acres around the nation are at risk of insects and disease, with the mountain pine beetle once again the likely top agent. This map shows that the risk of insect and disease outbreaks can be grouped into some clusters, many of which are located in the West. In this map, the watersheds that are most at risk for insects and disease are highlighted. Many critical watersheds throughout the West are at risk. Watersheds with less than 10% of forested land were excluded from this analysis. About half of the areas at risk from insects and disease are managed by the U.S. Forest Service, and 10% are managed by other federal agencies. State, county, and private lands account for the balance. Let's review some of the main points from this presentation. Wildfires are a natural part of western forests and essential to maintaining ecosystem health, but decades of fire suppression have caused an unnatural buildup of fuels in some areas. Wildfire activity varies considerably from year to year, largely due to weather conditions, but blazes are generally getting bigger, burning longer, doing more damage, and costing more to suppress. An increasing number of acres are being treated with mechanical thinning and prescribed burns, but the backlog is tremendous, and there is some disagreement about where to focus the work. Climate change is expected to increase wildfire activity in the West, and scientists have found evidence that it has already increased the length and severity of the West fire season. Wildfires are bound up in the larger issue of forest health, with insects, disease, and climate anomalies causing numerous episodes of tree mortality in the West. Thanks for watching this presentation. You can download it, as well as other slides and entire libraries, at EcoWest.org. A number of leading experts on Western conservation serve as advisors to EcoWest. EcoWest is produced by California Environmental Associates. Please feel free to contact us if you have a question or want to make a suggestion.